Now, let's head straight into motion. Types of motion. First of all, we have to understand what motion is, okay? This is the definition of motion. This statement you have on a blue background here, okay? This white statement is the meaning of motion. So, motion means movement. That's motion. A kind of movement of an object. That's motion. Motion is the movement of what? An object. And motion is brought about by force. So, force induces motion. Force is the power behind motion. And what are the types of motion? We have linear or translational motion. Why is it called linear or translational motion? You know, when you say something is linear, it means straight line. So when you say linear motion, you mean motion in a straight line. Or you can also call it translational motion. So a motion like this is a linear motion or translational motion. And an example of this motion along a straight line is a car on the highway. A car on the highway is what? Is a motion. But if that car is not on the highway, maybe because of traffic jams, okay, it's no longer translational motion. It becomes random motion because the car is going to be moving in a zigzag manner like this, in a zigzag manner because of a traffic jam, or the one they commonly call hold up or go slow in Nigeria. So the next we have here, other types of motion is rotational motion. And what is rotational motion? It's a motion about a fixed axis. About a fixed axis, okay? So there is a motion about a fixed axis. So there is a fixed axis. So for example, the spin of a fan blade, you have the fixed axis here, while the fan blade spins about the fixed axis. The next we have here is oscillatory motion. And oscillatory motion is also called back and forth motion, or you can call it what? To and fro motion. Either you call it back and forth motion or to and fro motion about a mean position. So there's always a mean position, okay? It's just like a fulcrum or the center of the to and fro movement, where the fro side meets the toe side. For example, if the to and fro movement is like this, for example, this is the oscillation. For example, this point up here is the mean position. It meets here. The one you have down here or below is also the mean position. So it hits both the to and fro. Or if the to and fro movement is like this, like this, like this. So the mean position should be here. That's either the toe is hitting or the fro is hitting. Or either the back is hitting or the forth is hitting. So that's the mean position. For example, to and fro movement is observed in pendulum. You know pendulum bulb that oscillates like this, like this, like this. I will give you another example of to and fro movement. Another example of to and fro movement is an object floating in water. So the water waves gives it that to and fro movement. And the next type of motion we have here is random motion. And it's also called the irregular motion, like I said. For example, when you say a motion is random motion, it has a zigzag motion. It's a zigzag motion, zigzag movement, not straight. For example, gas molecule, you know how gas molecule they behave now. They just bombarding everywhere, the container of the gas and all of that. So another example of random motion is when the housefly is flying. The flight of a housefly, that's also a random motion. Fly when they fly like this. The flight of a housefly, that's also random motion. So what are the Newton's law of motion? Let's find out. Newton has 3 laws of motion. The first Newton's law of motion is also called the law of inertia. And what is inertia? Inertia is that force that keeps a body at rest. According to the definition we have here, it says inertia is resistance to change in motion. So that force that prevents that body from moving, that thing that forces the body to be in one particular position is known as inertia. So the resistance to change in motion is inertia. And what is mass? Mass is the amount of matter contained in a body. The Newton's second law of motion states that force equals rate of change of momentum. So the rate of change of momentum of a body or system is directly proportional towards the applied force. The change of rate of momentum of a body or system is directly proportional towards the applied force. Any force applied on a body is equal to the change of rate of momentum. If I use my leg to kick a ball now, that is the force. That kick I kick that ball is the force applied to that body, which is the ball. The force I applied to that body is going to determine the momentum of that body. If the ball was moving slowly at a slow momentum before, then I move closer to the ball and I applied force. I apply force to the ball from the external. I apply force. That force I applied is going to determine the change of momentum of that body. If the ball is going to roll faster or is going to remain in the same motion or position. So let's look at the formula of the Newton's second law. This is the formula. F is equal to mass times acceleration, which is force. Okay, when mass is constant. So the relationship is larger mass is directly proportional to smaller acceleration for same force. So when the mass of the body or the object is higher or is high, what is the effect on the acceleration of the body? The effect of such a mass on the acceleration of the body is smaller acceleration. So we are trying to say the heavier the object, and you apply the same force. For example, 10 kg block, you apply the force of 5 Newton to it. And you come across a 20 kg block and you are still applying the same force of 5 Newton to it, and you want a change of rate of momentum, it's going to yield a smaller acceleration because the mass is larger. Hope I was understood. The third law of Newton states for every action there is an equal and opposite reaction. So that's it. It's very simple. For every action there is an equal and opposite reaction. For example, when you fire a gun, you fire a bullet from a gun, you are going to feel this recoiling force like this. So when the bullet comes out of the barrel of the gun, that is an action. You propel a bullet with a propulsive force. But in turn, there's going to be an opposite reaction. You are going to feel this recoiling force backward. The gun is going to pull backward like this. And both of them are equal. The firing force of that bullet is equal to the recoiling force of the gun. So let's look at the example we have here. The example states rocket repulsion. It's just like the same thing I explained for the gun concept. Okay, a rocket repulsion. This is the rocket, for example. This is the place that gas normally comes out from the rocket. As the rocket moves in space, this is where the gas comes out. The gas, the power from the gas, the pressure from the gas pushes out. That's it, pushes backward, opposite direction. And because of this pressure from the gas, the force from the pressure of the gas, it produces an equal and opposite force. Equal and opposite force, the same direction. So this force is acting forward. That's why the rocket moves. As the gas pushes, as the gas pressure backwards the rocket, that recoiling force moves the rocket further into space. Equal and opposite reaction. Impulse and momentum. Take note of my color coordinates. The first we have here is momentum, and this is the symbol for momentum. It's like P. Okay, so what is momentum? Momentum can be defined as the mass times velocity. It is the product of a body's mass and its velocity. The product of a body's mass and its velocity. So mass times velocity equal to what? Momentum. I want to explain momentum to you now. I want to use this my hand to slap you now. So how do we find the momentum of the slap? The momentum of the slap is the mass of my hand. You are going to scale this my hand to find the mass of this my hand. Then when you find the mass of this my hand, you are going to times it by the velocity at which I threw the slap. The velocity at which I threw this slap. And you are going to times the velocity with the mass of this my hand. The product of two of them, like this, everything, that is the momentum. That's why when the momentum of the slap is high, it's going to be very, very effective. Can even cause you deafness. The second we have here is impulse. Okay, and this is the symbol of impulse, J. And what is impulse? Impulse is the product of force and time. So when you times force and time, you get impulse. So force times time equal to impulse, as easy as ABCD. And what is the SI unit for impulse? It's very easy now. Is the SI unit for impulse is Newton second. Yeah, just find the SI unit of force, Newton. Find the SI unit of time, second. Yeah, same as momentum. What is the SI unit of momentum? The SI unit of momentum is kilogram per meter square. So the SI unit for momentum is kilogram per meter. So impulse is equal to change in momentum. Have that in mind though. Change in momentum means final momentum minus initial momentum. That's change in momentum. You minus the two momentum. What you get, that's the change. The difference in momentum, that's the change. So anywhere you see this thing like triangle like this, it means this is called delta and it stands for change. Okay. So Ft, which is impulse, force times time, is equal to what? Change or delta momentum. As easy as ABCD Shikina. So Jamb can ask you a question. So Jamb can set a calculation question for you of a body. A final momentum of 7 and they give you an initial momentum of 5. They will now tell you to what is the impulse of the body. Remember, you were not giving force and you were not giving time. Since impulse is equal to change in momentum, what do you have to do? You minus initial momentum from final momentum to get the impulse or change in momentum, because impulse is equal to change in momentum. As easy as that. Conservation of linear momentum. What is linear momentum? Linear momentum is that momentum in a straight line. That is linear momentum. That momentum in a straight line. I already told you before that anywhere you see linear, it means line, straight line, on a straight line. Okay, that is linear. In a straight line, linear, a straight line. So a momentum in a straight line. So what is the law of conservation of linear momentum? The law states in the absence of external force, that's when there's no external force acting on the body, total momentum of a system remains constant. So when there's no external force acting on the body, the total momentum of the system remains constant. In that system, no external force at all. The momentum remains constant. That momentum of that body is constant. If I'm working at 5 kg per meter second as my momentum, and no external force acts on me, that my momentum 5 kg per meter second is going to remain constant until I head to my destination, until I decide to stop working, or an external force acts on me, which is going to make me stop. So I am going to continue moving. The momentum is constant, provided no external force acts on it. For example, if you put a car on the road now, at a given momentum, that car is going to continue moving until an external force acts on it to stop it or whatever. So that's the law of conservation of momentum. So this law helps to conserve momentum, for momentum to last for a long time. That's it. Momentum is not wasted. Momentum is not destroyed except an external force acts on it. For example, two colliding cars. This is the formula for solving linear momentum. Very easy. What do you have to do? Mass 1. Then this u is initial velocity of mass 1. Then mass 2. This one is also the initial velocity of mass 2. Equal to mass 1 and final velocity of mass 1 plus mass 2 and final velocity of mass 2. If you solve what you have here, basic mathematics, you times this one, then you plus it by what you get here. If you do the two sides, what are you going to do? You divide both sides to get your answer. So when you are asked using the law of conservation of momentum, what is the linear momentum of so thing in your Jamb UTME? This is the formula that you are going to apply. It's easy. Mass 1 times the initial velocity 1 plus mass 2 times the initial velocity 2 equal to mass 1, the same thing, but here you are not using final velocity, plus mass 2, final velocity 2. Very easy to solve. Just substitute and you get your answer. This formula looks a bit long, but it's very easy to know. It's very easy to put in your head because the formula is straightforward. Note something very important. It is the basics for rocket motion and collision problems. So this law of conservation of linear momentum is the reason why rocket moves in space without stopping, because the momentum is constant, is constantly moving. That's it. It continues to conserve momentum except an external force acts on it. Force as a cause of motion. Like I said before, at the beginning of this lecture, I told you that force is the cause of motion. Looking at the left hand side of your screen, force is a push or a pull that changes motion. Yes, a push or a pull, like a tug of war, that is force, or a push. Both of them are applied forces. So what are the examples of a push or a pull? For example, this feature of force that is push or pull, what are the examples? Push is, for example, kicking a ball. You push it with your leg. Hey, maybe this is the ball. You use your leg to push it. Hey, that's a push. Then a pull is what? Drawing water from the well. So a pull, drawing water from the well. You are pulling. So the two difference of this is that pushing is pushing away from you. It's away from you. The movement or the motion is away from you. While pulling is bringing something closer to you. That is the major difference between a push and a pull, when someone is the one carrying out the push or the pull. Looking at the right hand side of the screen, you have field forces. And what is field forces? It's simple. Field force is the forces that acts without contact. Contact is not required. Okay, no contact required, but this force will act. It's not like I put my head now, you want to slap me, and you don't feel dead that side, you don't say I have slapped you. No, no, is it spiritual slap? No, you must come close to me and give me that slap. Hey, it must land for my face. That is not a what? Force field. A force field is a field whereby something, an object can be there, but experiences the force from another object distant without having any direct contact with that object. And let's look at the examples of force field. The first we have is gravitational pull. Okay, earth on object. The way the gravitational pull or the gravitational force in the earth crust pushes all the objects in the earth downwards. The next we have here is electric attraction / repulsion. That's for charges. You know electric attraction now. So contact is not needed. Like the one we just explained for gravitational pull. You jump. When you jump, you are going to fall down because of the force applied by gravity on you. Just as being an earthling. Because you are an earthling, you are found on this earth. That gravitational force must act on you. It will continue to push you down, push you down, push you down. So you can't just go up and just hang there, except there is a resisting body, something that is keeping you there on that height. You can't just jump and be on the air. No. So contact is not needed. You jump and you fall down. Something pulled you down, but you didn't see that thing, but nothing touched you. So that's a force field, a field where a force is experienced without contact. So you know what charges do? Electric charges, they like charge. They repel each other. Okay, they repel each other. That force of repulsion. Okay, they repel each other. But unlike charge, attracts each other. Okay, so there's actually no contact, but force is felt. The next one we have here is magnetic attraction / repulsion. Okay, for the north and the south pole. Two north pole can't attract. Same as two south pole can't attract. Okay, so you need the north pole and the south pole to attract in magnetism. So that's why you can put a magnet here and you put an ion here. You are going to notice that attraction. You are going to notice the attraction, the force field, without bringing the two objects together, without bringing them into contact. Okay, so that point where you notice that attraction, okay, that surrounding, that area is called the field of the force. Okay, so depending on the force that you are experiencing, is it magnetic force, is it electric force, is it gravitational force, which of the force field that experiment is left for you to carry out. So guys, let's test the knowledge we've acquired so far with some Jamb must repeat questions. Jamb must repeat questions. Question 8. Which of the following best illustrate the law of inertia? A ball rolling on a smooth floor continues until friction stops it. B. A rocket moves because gases are expelled backwards. C. A car accelerates when the engine applies force. D. A magnet attracts iron filings. Drop the answer in the comment section. Question 9. A force of 10 Newton acts on a body for 5 seconds. What is the impulse delivered? A. 2 Newton seconds. B. 15 Newton seconds. C. 5 Newton seconds. D. 15 Newton seconds. Drop the answer in the comment section. Question 10. Two cats of mass 2 grams and 3 grams move towards each other with speed 4 meters per second and 2 meters per second respectively. So when you say respectively, it means that this first speed is for the first mass, the second speed is for the second mass. So they now ask the question, if they collide and stick together, what is their common velocity after collision? After collision, is the answer A 0.4 meters per second? Is the answer B 1.6 meters per second? Is the answer C 2.0 meters per second? D 3.0 meters per second? Drop the answer in the comment section.